everybody. Welcome to my talk. We're talking about AI today, which I know is a bit of a spicy topic. Title of the talk is Fake Minds Think Alike. I'm gonna take this off so I look better in pictures. Okay. Fake Minds Think Alike, AI, Ruby, and Similarity Search. My name's Valerie Woolard. I'm a software engineer at Heroku. I made this fun little illustration with ChatGPT. You can play a little game and see how many odd things that you can spot in it. I like the monitor facing the wrong way, personally. I've got my socials linked at the bottom of each slide. If I'm honest, I don't really post anymore. But if you want to write nice things about me or this talk on any of those platforms, tag me and I will read them. If you write mean things, I'll read them and pretend I didn't. So I'll start here with a quick introduction. As we went over before, I'm Valerie. I'm a principal data infrastructure engineer at Heroku. I work on the team that runs Heroku Data Services, so Heroku Postgres, Valkey, Kafka. I'm actually going to be moving over to the Heroku AI team pretty soon, so I'll be working a lot more with some of the topics in this talk. And on the data team, I led the project to add pgvector to Heroku Postgres. I studied cognitive science and computational modeling of cognition once upon a time, but suffice it to say that a lot has changed in that field in the time since I've graduated university. I'll leave it as an exercise to the reader to figure out how old I am, but suffice it to say the state of the art is quite different now. I'm also the president of Ruby Central, which is not terribly relevant to the content of this talk, actually, but I figured I should mention it. If you'd like to chat about Ruby Central, also happy to do that later on. My most notable project of the past few years is actually that I grew a human being in my body. This is a photo of my, thank you for the applause. This is a photo of my husband John and our baby Remy at Buckingham Palace last week. I had this delusion that Remy was gonna come see this talk, but I realized last minute that sitting quietly in an auditorium is not really a skill that he has on his resume just yet. If you happen to see me around tomorrow, there's a good chance I'll be wearing him in this little backpack contraption, though. Okay, so let's get into it. What is AI? It's what this talk is about. But AI is a really broad term that can be used to refer to a lot of things. It's used to refer to applications of machine learning, game theory, natural language processing, Bayesian networks, computer vision, neural networks, large language models, and more. But today's talk, and most of the current discussion around AI when people mention AI, refers to large language models, or LLMs. And as you can see in this graphic that I stole from a Medium article by Microsoft, LLMs are actually a pretty small part of AI broadly defined. They take huge quantities of unstructured data and render it into computer legible formats. The big idea of AI is making computers learn, reason, and perform like or better than human brains. The problem with that is that human brains are actually not that much like computers, as far as we can tell. As you probably know, as a software engineer and computer person, there are plenty of tasks that computers are much better at than human brains, and others that they are, in fact, much worse at. Computers don't learn like human brains. You didn't learn to play chess by modeling thousands upon thousands of chess games in your mind. Computers don't actually behave much like human brains as far as we can tell. Brains aren't closed controlled systems where you can expect the same results given a fixed input. They are living, changing, wet organs. Artificial intelligence has been created by humans in part to avoid some of the elements of human bias and fallibility, but those biases will exist in the data that's used to train the algorithms, and therefore the models that result from them. LLMs will also sometimes hallucinate and create content that is not supported by training data, and they can't be relied upon to create logically sound or factually accurate output. Let's get into some of the controversies around AI. There are plenty of them, and reasons that folks might be reluctant to use it, even in cases where it could be a helpful tool. There's no accountability for times when AI makes a mistake. I've included in this slide a famous IBM presentation from 1979. A computer can never be held accountable, therefore a computer must never make a management decision. Using AI as a substitute for your own thinking, reasoning, or managing is a mistake. And if your AI code assistant ships a bug, you shipped a bug. As we touched on also in the last slide, AI doesn't actually behave that much like a human brain, even though it can sometimes feel like it does. So your AI code assistant is likely to make very different errors than you might get from a junior developer working on the same code base. And as we use AI code assistants more, it can be harder to identify those errors if you're used to working primarily with humans, for example. There's also concern around the environmental impact of using AI. Large amounts of resources go particularly into the training of large language models. And then there's the issue of intellectual property. Many of these models were trained on copyrighted or otherwise protected data without the rights holder's consent, and not everyone wants the content that they create used to train AI models. There's also plenty of claims for what jobs AI could replace, like marketing, software engineering, lawyers, et cetera. Some companies have laid off human beings and replaced them with chatbots, which generally goes as well as you'd expect. And finally, lots of people use AI to do things that they really shouldn't, like draft legal documents, because they don't understand how it works. I've heard AI referred to a lot of times, especially the current generative AI craze, as a hype cycle. And this is a graphic about what's called the Gartner hype cycle. And I found it really interesting to look at in the context of the current AI environment. I think you could make the argument that we're currently at different points in this current AI cycle. I'm inclined to think that we're around stage 4, where more instances of how the technology can benefit the enterprise start to crystallize and become more widely understood. Second and third generation products appear from technology providers. More conservative enterprises start to fund pilots, but some people continue to hang back. Where I think we're definitely not is stage 5, the plateau of productivity, where mainstream adoption starts to take off. Criteria for assessing provider viability are more clearly defined, and the technology's broad market applicability and relevance are currently paying off. I think there have been a lot of big claims made about what AI could and should do. I'm not sure that we've really crystallized what it's best at and what we should be using it for. And I think that we, especially even those people who are maybe a little bit more wary of using it, should be a part of that conversation. I do think we'll eventually get to stage 5. We will find viable long-term use cases for generative AI, and it will be part of the mainstream. So I think it's worth thinking about ways that it can be used as a tool, even for the more skeptical among us. Another point that I think is worth noting is that there have been many other AI hype cycles in the past. many of them concerned with other pieces of what AI means, like I showed on one of those earlier slides. The results of those have also worked their way into how computers work today. It was, for example, not that long ago that a computer could not reliably beat a human being in a chess match, but those days are over. So let's talk about AI. There are lots of new tools in the generative AI category. That's AI that creates new things, like images or text. They're trained on vast quantities of data. We talked about LLMs. And now we're going to get into the actual data type that's used by those LLMs, which are vectors. They're computer legible representations of human legible data. And the thing that AI is very good at, that LLMs are very good at, is pattern matching. But it's not creative or logical. I wanted to demonstrate how good AI is at pattern matching. This is one of my favorite emojis. It's man in business suit levitating. And I gave ChatGPT a picture of me to make Valerie in business suit levitating. So I thought that was really fun. We're going to go into some code now and learn a bit how these LLMs work and how they can be used to build something like a similarity search. And we're going to be using some Ruby. So vectors are the data type that I talked about. They're the building blocks of LLMs. We won't be going into too much depth because my time is short. Feel free to read more on your own if this explanation feels too hand-wavy, but it's also not really necessary to understand exactly how vectors are formed mathematically to understand their utility. They're numerical representations of complex data. They're necessary for generative AI, but not all uses of vector in AI are generative AI. Sentiment analysis, similarity search, image classification, and others are examples of AI applications for vectors. The actual data type of a vector you've probably worked with if you've done any sort of linear algebra. They can be expressed as a list of numbers, which you can think of as a quantity in n-dimensional space. And the big idea here is that similar things should be close to each other in vector space. And things that are different in the same way will differ across the same dimensions. We've got this sort of simple illustration of what some word vectors across 7 dimensions might look like. So we've got the words man, woman, king, and queen. And then we've kind of plotted them out on this graph. And you can see that man and woman are about the same distance apart in the same direction as king and queen. And so that's a visualization of how that word embedding might work. It's worth noting this is a simplified illustration. Most of the vectors you're going to be using will be many, many more dimensions than this. I think the typical hugging face vector embedding is 384 dimensions to this one's 7. So it's not that easy to visualize something in 384 dimensions. At least it's not for me. So we'll leave it at that. Here's an illustration of a process of how you might use vectors with your own data. You'd start with your own unstructured data, such as text written in normal prose. You'd feed that data into an embedding model, and that model will output an embedding, which is a vector like we saw in the last slide. It'll just look like a really long list of numbers. Sentence transformers is what I use for some of these examples. It outputs a 384-dimensional vector. If you're looking to build a similarity search for your data, you'd encode that data that you want to search over as vector embeddings, and then perform just a distance formula, a nearest neighbor search to find related items. So let's get to code. As many of you who've maybe tried to use these tools before will probably realize, most of them are Most of the most popular tools are not in Ruby. They are, in fact, in Python for the most part. But I can use any type of gem to control any type of snake. Python has a lot of the latest hotness, but there are Ruby gems for a lot of those providers too. And when all else fails, there's HTTP. Here's just a slide of word salad of the various tools you might find helpful if you're building an application in Ruby or Rails that uses vectors. There's Pinecone, which is a vector database. There's Postgres, which has the pgvector extension, which adds vector data types. It's available on Heroku or whatever Postgres implementation you have, probably. You can use SQLite and SQLite vector. You can also use Valkey as a vector storage data store. In terms of gems that you might want to use, pgvector has a gem. There's also Neighbor for Rails to do the nearest neighbors searches. OpenAI Ruby is just a Ruby wrapper for a lot of the OpenAI APIs. And then Informers, which is actually the one that I used in some of these code examples. So you've decided to build a similarity search. Great. Now what? Some of the considerations that you'd want to take into account is what data you actually want to feed to the embedding model. Say you've got a website shop. You have item descriptions. That's probably a pretty good thing to include. If you've got a model with a really broad context window, maybe you want to feed in even more. Maybe you want to feed in some product reviews. Maybe you want to feed in the name of the item, some other specifics around that item listing. You'll want to think also about what model that you want to use for those embeddings and how that model was trained. Sentence transformers, which is what I'll be using in this example, it was trained on Yahoo Answers, Reddit, Stack Exchange, Wikipedia, WikiHow, and other internet content. An important thing to note is that a model that was trained on data closest to your use case is going to perform best. So if you're, say, doing classifications on a bunch of medical data, you probably want a model that was trained on medical data, not on Stack Overflow. Okay, so for our example, let's just say, for no reason, I'm sure this isn't relevant to anyone here, I have a huge to-be-read list of books saved in a database, along with each book's description, and I'd like to pick a new book to read. So I've added embeddings of each of the book's descriptions generated from the Hugging Face Sentence Transformers model. And I can then query my database by telling it what I'd like to find. I'm in the mood for a quirky, magical, realist fable. And then using similarity search to find the closest match. As you can see, the result it gave is The House in the Cerulean Sea. I'm not sure how many folks have read that book. I have not. It's on my to-be-read list. This was my real to-be-read list. But let's read a bit more about it. Let's look and see if that would actually fit the bill for a quirky magical realist fable like I asked. It's a thoroughly enchanting novel that follows lovable Arthur, the caretaker of magical misfit orphans from around the world, full of whimsy, romance, and a touch of intrigue. Will make you smile from the first word to the last. Seems like it's done a pretty good job. Okay, so what if I'd prefer a bit more of a personal touch instead of just spitting a result back? I could use what's called retrieval augmented generation to use generative AI prompts plus relevant documents from a user query. So this is just a little flow chart from Wikipedia on how to construct a RAG query. But basically, you're giving the LLM a bit more relevant context in the prompt to generate a better response for you. So you've got your vector database that you're querying against. to pull back the most relevant pieces of context through something like a similarity search. And then you're using those results to build your augmented query. So for example, here's how I might use retrieval augmented generation to tell me about my next read. I would send this prompt to a text generation model, filling in the variables with user input. So I'm looking for, and fill in my interests, in my case, a magical realist fable, for my next read. Tell me why I might like The House in the Cerulean Sea, and then pasting in the description from my database. And then that text generation API would spit back like a paragraph of why I might like this book and why it might apply to my interests. One thing I glossed over a bit before is that some models have much bigger context windows, and you could potentially put way more information into your RAG prompt. This is something that might get around things like maybe not every book description is going to tell you exactly what the book is about. Some of them are a little mysterious. Some of them might not actually make it as clear what the genre is, what people think of it. So you could potentially put way more information. You could include user reviews that you might have handy. You could include descriptions of other books that you have, or more about books that you like to enhance that prompt. Some other implementation ideas that you might use with something like that is finding related articles and texts, allowing people to search content with natural language. So instead of relying on, categorization and tagging, just letting people type in something that they're looking for and search across documents to be able to find, hopefully, things related to that, even if they're not using the exact right search terms. It could be used to categorize images. And the big idea here is I'm hoping that this has given you one practical potential application for vector search in AI, but I leave it as an exercise to you to find other potential ideas. And that's the end. I'm not actually going to be taking questions up here, but do find me in the foyer or on social media, and I'd love to chat some more. Thank you.